Hi, Mia. Hello, can anyone hear me?
Yes, I'm here. Tuhan kita bacain doang ya Allah.
Udah dibilang kalau kasih tahu tadi.
Terus itu tapi belum semuanya udah masuk mas. Tanggal itu udah ya.
Udah.
Oh itu menyiaskan.
Udah masuk ya. Udah dengar lagi tanya bayar saya.
Oh, tapi kenapa belum ngomong?
Yang ke rumah siapa ya? Ini udah warga rumah ya? Ada.
Iya bang.
Karena ini katanya ada orang dia muncul. Semuanya
Oh iya cuma
ya.
Iya.
Perempat ada peserta yang katanya tampilan slide dari tiketnya tidak kelihatan. Kamu cek mau tampilan.
Mita lu tahu nggak Mita?
Wait, baik ya.
Mita. Mita itu sinetron. Yeah, hello, Miss Lisa. Hello, Miss Lisa.
Okay.
Yes.
Hello.
We can hear you, but we are still waiting for Miss Mia to come in.
Okay. Thank you.
But you can start the presentation actually because
Okay. Thank you.
Okay. Thank you. Yes.
I'm just checking if you can see my screen well.
Yes, we can see your screen.
So you see the presentation in a presentation mode and everything's okay. And apparently you also hear me well.
Okay.
Okay.
You can
Thank you.
start now. Thank you.
Yeah. Thank you. Okay. So thank you everyone for joining. My name is Liisa Otama. I come from Thermo Scientific, and I was invited here by our very valued and trusted partner, ENSEVAL MEDIKA PRIMA. Unfortunately, our panelist from PT ENSEVAL, Mia, is having some audio challenges, but she will be joining us, and she will also able to speak Indonesian. So, but I will start now. This presentation will be in English because my Indonesian skills are very poor. The topic for today is how to improve your quality and efficiency of water and environmental chemistry testing with automated discrete analyzer. For starters, just a few words about me. My name is Liisa Otama. I'm a senior product manager at Thermo Scientific. I'm actually located in Finland, where I sit right now. We have a winter coming. And we also have a Thermo Scientific manufacturing site. And the products that I'll be talking today are all manufactured here in Finland. I have over 10 years of experience working with these discrete analyzers and related applications. During those over 10 years, I have worked with numerous environmental and water customers all over the world, including visited some customers in Indonesia as well. My responsibilities, in addition to the food, to environmental testing, include also food and beverage and the IVD, so the clinical diagnostics testing. Let's see. Okay, let's move on. Please feel free to interrupt if the audio is not working properly, or if you can't see my screen. We have the questions and answers box to which you can add any questions you may have during this presentation. You can write in English or in Indonesian. So we do have panelists who speak both languages. To get started, I think in order to understand how we can improve, we need to also understand the challenges that we are facing. When we think about the traditional wet chemistry analysis, we can roughly divide the methodologies into 4 groups. We have the volumetric methods, we have colorimetric methods, gravimetric methods, and then this bunch of other different methodologies. Often these wet chemistry methods require quite a bit of manual work, and a lot of the methods are done purely manually. So this is very classical approach. Liquid samples require a lot of work, preparation work, but also the reagent standards need to be manufactured or prepared manually. Often these are quite prone to this user error. So depending on the operator, you might see slightly different results because the detection is often done visually. Like if you think about the manual titration. Obviously, rather labor intensive due to all these manual steps and then time consuming. This is of course something that I have seen firsthand when visiting the customers. I'm sure that you all have your own challenges, and that's the reason why you've joined the session. Excuse me, did somebody comment?
Hi, Lisa, this is Ryan.
Hi, Ryan.
Sorry Sorry to interrupt, but the presentation is not in the presentation mode.
Okay, thank you, Ryan, for informing me. Let's see, because I have two screens here. Is it better now?
Yes, thank you.
Thanks, Ryan. Yeah. Technical challenges. This is something we need to deal with when we are in this new normal virtual world. Okay, moving to the next slide. So majority of customers that I have worked with, they do test a lot of different parameters from the same sample. So when the sample arrives, most likely what you also do is that you have to divide the sample into aliquots to do a various parameters. So from a single sample, you would do multiple different parameters. For example, if you do the wastewater testing, you would be probably looking at the nitrogen, cyanides, phenols, boron, aluminum, other metals perhaps, or corrosion indicators like hexavalent chromium. Silica, calcium, magnesia, ammonia, other nutrients, nitrate, nitrites, anions, and then the basic water testing for alkalinity and total hardness. And then in addition to those, you most likely are testing pH and conductivity of your samples. In order to do this all, you most likely need to have multiple instrumentation, or you would have multiple technicians to do the work. So if you do manually, you would need to have persons to carry out the manual work, or you would need to have multiple instrumentation to do to automate or semi-automate this testing. And the typical workload probably would look something like this. So you have your samples for multiple analytes. You have multiple reagents and standards to be prepared, and most likely you are doing these yourselves, or maybe you buy elsewhere. Multiple instruments, and of course, the more instruments you have, the more maintenance is required. So each of the instruments needs to be periodically maintained. You need to calibrate the instruments. Different instruments have their consumables. In the worst case, each of the instruments have their own consumables, and you need to have multiple users. So multiple users mean that the training, heavy training load for each of these instrumentations or techniques that you are using. Turnaround time is most likely rather long. So from the start to the result, it takes quite a long time with all these manual prep times, and especially if you don't have that many persons working in your lab. So one person is trying to cover all. What this ends up with is a loss of time and money. So it's expensive to do all these, and it takes a long time, which ultimately results to a poor profitability. Most likely, if you do titration methods, or you have maybe flow analyzers, you would be using maybe up to 100 milliliters of sample per test, milliliters of reagents, and you are generating a lot of waste. Again, multiple instruments, and still you get your results in sequences. So you don't get the results for one sample at the same time, but you get results here and there, depending on all the different tests that you are doing. Often also, you can only do just one parameter from the same sample at once, or if you have flow injection analyzers or segmented flow analyzers, maybe maximum 4 parameters at the same time, depending on the channels you have. Still, if you want to have, if you have these semi-automated instruments like flow injections and you have the 4 channels, then if you cannot really choose which of the tests you would run for which of the samples, but you need to do all those, so always in a batch. And the analysis cost is pretty high due to this high consumption and high manual work that you're doing. I think this slide rather well summarizes the main problems that we see when we work with environmental customers. So again, when you want to do multiple parameters, you most likely need multiple instruments. So multiple testing methods for each of the sample. A large sample volume is required and the reagent consumption is rather high with a significant waste generation. Multiple instruments, skilled users required, and of course, these are labor and time consuming. So the impact on your laboratory, which is probably the reason why you are here today listening me, is that you want to reduce the long hands-on time, improve the throughput, and improve the result accuracy. So you don't want to have all those user errors which are simply due to the handwriting on each of the operator. You might want to get rid of this frequent maintenance, because that, of course, it impacts your profitability. If you have your instrument down due to this maintenance, you might even have to send the samples someplace else to be tested, or just wait for the results to come after the maintenance. And of course, maintaining the user skills and trainings is probably something that you want to reduce. I have now been talking quite a long time about the challenges and the problems you may be facing in the laboratories. But of course, the topic for today is how to improve. So we are offering you a solution. We have the Thermo Scientific Gallery Discrete Analyzer platforms, which can consolidate your testing, and it rapidly runs multiple parameters simultaneously. The methods that can be done, for example, the colorimetric or turbidimetric methods, enzymatic methods, or electrochemical methods. Or if you choose, you can run all these simultaneously. So while the instrument would be running your routine nutrients, for example, it can also do pH and conductivity at the same time. So we are offering you this automation to improve your efficiency and the quality. I think this picture rather nicely illustrates how we can simplify your processes. On the left-hand side, we have this traditional approach where multiple parameters require multiple instruments. We have a long list of assays that all need to be tested, and we have a long list of also different instrumentation that would be required. On the right-hand side, we have a single instrument, the gallery analyzer, and we have equally long list of parameters that can all be done with this one single instrument. This is how you can simplify and how you can improve your efficiency, consolidate your water testing. Looking at the gallery workflow in comparison to the traditional ones, again, we do have our samples and we do have the need to test multiple parameters. The difference to the traditional approach would be that here we have ready-to-use reagents and we have ready-to-use standards. And we have a single instrument. So we have a full system solution to be offered to you. Reagents and the instrument, and of course the method. So the applications are already programmed into the instrument. What you need to do is you need your operator, place the reagents in, place the samples in, and ask the instrument to run your testing. Because the instrument is doing multiple assays simultaneously, you do get the results very, very fast. This will not only increase your productivity, but also the profitability. So saving time and saving money. Comparing, for example, the reagent consumption between the Gallery platform and the traditional approach. Here we are talking about microliters of reagents. So reagent consumption anywhere between 2 microliters to 120 microliters, depending on the composition of or the reaction component. It might be maybe roughly 200 microliters per test. We are only generating few milliliters of waste, which majority is the DI water that we use automatically to wash the probes. And again, we have a single platform, so you need to do only one maintenance or maintenance only for one instrument. You need to have consumables only for the one instrument, and you need to have the operator only for one instrument. And the best thing is that because this is fully automated, it also offers you this walk-away time. Once the instrument is loaded and the analysis starts, the operator or technician can actually focus on doing something that really matters to make your lab even more efficient. So the operator does not have to sit by the instrument and watch it do its work. The operator can actually focus on something a lot more productive work. And again, we do multiple parameters per sample, and the cost per analysis is significantly lower. Even if you would simply automate your current manual methods and use the same reagents, you would be able to reduce the reagent consumption 10 to 100 times lower. So from the same amount of reagents, you would be getting at least 10 times more tests. So that's what I call savings. How does this discrete analyzer actually then work, or what's the basis of it? It is a photometric instrument. And it has filters. We have this very long-lasting xenon flash lamp, which has this spectral range from 275 to 880 nanometers. In practice, it will be 340 to 880 nanometers. We have a fast rotating filter wheel with 12 positions. So you have possibility to have 12 different wavelengths that can be used in your measurements. Of course, each of the wavelengths can be used in multiple different assays. The light that comes through the xenon lamp goes through the filter, which rotates very, very quickly. And it is directed through this optical cable towards a beam splitter, or there is a mirror which directs roughly 10% of the light to the reference detector. This way we know then how much light is actually going through or coming from the lamp. And then the rest, roughly 90% of the light, is directed through this cuvette, decacell cuvette we call it, which is the actual reaction vessel. After the cuvette, we have our detector, and the detector knows how much light has passed. And that way we are able to calculate the actual absorbance in the cuvette or in the reaction. Following the basis of the photometric measurements, the absorbance is directly proportional to the concentration. All the calculations are done manually by the instrument, and all this is automated. So you will simply get your results out. You don't need to do additional calculations offline. And here is what our gallery analyzers look from the outside. We have two models. We have the gallery, which has two covers, so slightly smaller one. And then we have the gallery plus, which has three covers, screen covers, and slightly bigger. On the main difference is that on the Gallery Plus, we have separate reagent compartment and sample compartment, whereas in the Gallery, these are combined. The throughput is then slightly different. So with Gallery Plus, you can do roughly 350 samples per hour, whereas with Gallery, it's about 200. So there is a difference not only on the capacity, but also in the throughput. The great thing about this instrument is that these are, they are benchtop, but they're also self-containing. We have a DI water containers, and we have waste containers, both for the cuvette waste and the liquid waste. And what this means to you is that you can very conveniently place these instruments in a bench in your laboratory to a location that you feel the most suitable. You don't need to think about the water connection, or you don't need to think about or worry about the drainage. The instrument is self-containing, so you can place it almost anywhere in the lab. Of course, regular laboratory requirements, but very, very convenient for you. And that's one of the reasons why these are so popular, because the customers feel that it offers them this additional flexibility. Of course, just coming back to this one, of course, it also means that with these instruments, you don't need to invest, for example, additional drainage or additional water supplies. So you can play with whatever you have in your lab, and you can add the instruments. So the installation of these instruments won't cost you extra. I think that's very, very important point as well. And then how does it look on the inside? This picture is about the gallery analyzer, so the slightly smaller one, where we have, first of all, the cuvette storage. So cuvettes were the ones that are the reaction vessels. So they are the ones that carry the sample and the reagents, and this is where the magic happens. We have place in the cuvette storage, we have place for 36 decacell cuvettes. We call the cuvettes decacells because each of the decacell actually has 10 reaction vessels, meaning that the storage can hold up to 360 measurement cells. We have our incubator. An incubator is where the reaction happens. This is temperature controlled, so the reactions always happen in under a controlled temperature. On the incubator, we have place for 9 decacells, meaning that we can have simultaneously ongoing 90 different measurements. So in practice, you could have 90 different tests up and running simultaneously. On the gallery analyzer, we have this combined sample and reagent disk, which can carry up to 6 racks. These racks will be a combination of sample racks and a combination of reagent racks. Typically, what we see is that there are maybe 2 reagent racks and then 4 sample racks, but depending on your workload and the amount of samples you have in the lab. We also have a combined dispensing probe, which automatically dispenses the desired amount. And we have an automated mixing procedure. So there's a mixer that automatically mixes the solution. For those who are also testing ECM, so pH and conductivity, we do have this optional ECM module, which also has its own dispensing probe. And for the Gallery Plus, which was the larger model, we have the same incubator, we have the same mixer, and we have the same cuvette storage. Then we have a separated sample compartment and a separated reagent compartment. The reagent compartment, by the way, is cooled. And on the Gallery Plus analyzer, you can have up to 42 reagents on board at the same time. So 42 reagent positions. And the samples, you can have now the full 6 sample racks. We do have the maximum sample capacity is 6 times 18, which makes it 108 samples. So in practice, what you can do is that you can load 108 samples at the same time into the instrument, press start, and leave the analyzer running. You can continuously unload and load the instrument. So once one of the sample racks is ready, you can replace it with a new one. So it is a continuous loading or random access instrument. We have separated sample and reagent probe on the Gallery Plus. And otherwise, it's very similar. So the same ECM option is available also for the Plus model. We did briefly also already cover the sample handling, but maybe the highlights here is that we do have two different types of racks. So we have 9 and 18 position racks, and with the maximum sample capacity is then 108 samples on board if you use the 8 position racks. You can use a mix of containers, so carriers for the sample. You can use cups or you can use tubes. If you use tubes, you can have the tubes barcoded. And then there is an automated or integrated barcode reader in the instrument, which comes by default. So there is no additional cost for that. Automated integrated barcode reader that identifies the tubes, which makes it even more convenient. And of course, making sure that there won't be any human errors on the sample handling when you have your barcoded samples. There are a lot of great features in the software. For example, the instrument will flag if the samples are expired or if calibrators controls are expired. So the instrument kind of keeps you on track what's going on. Reagents, I mentioned earlier that we do offer these, the full system solution for you. And we have these, in our offering, we have these ready to use barcoded reagents. So what it means, if we look at the left-hand picture, we see each of the reagents have barcodes. Again, we have this integrated barcode reader, so the instrument automatically identifies which reagent is which. The operator doesn't need to worry about that. All they need to do is place the reagents in a rack inside the instrument, and the instrument will know which reagent was which one. So again, we are eliminating any errors on the reagent handling. If there is a method you would need to run, you would want to run, and we wouldn't for some reason have it in our portfolio, it is possible to have user-defined methods and user-defined reagents. Those you would simply insert into the instrument manually. So that is not blocked. But with the barcodes, you get this very, very great features. For example, the instrument will monitor the reagent batch and the expiry date. It can even identify individual reagent bottles. The real-time reagent volume and remaining test capacity is informed. So instrument knows how many milliliters of reagent is left in the bottle, and it knows for how many tests it is sufficient. And when you have your samples loaded, the instrument will tell you, or it will warn you that this is not a sufficient amount. So really, really user-friendly and makes your lab work even more efficient. Of course.
Hey, Liisa, it is 5 more minutes. 5 more minutes. Time.
Really? I thought we had 45 minutes. Okay, so we are speeding up then quite a bit. Okay, DECA cells we already talked about. The benefits of the DECA cell cuvettes, individual reaction cells for each of the tests. 10 positions in each of the DECA cells, and what it means with these disposable cuvettes is that there is no need for washing, there is no risk of carryover because each reaction takes place in their own individual cell. The volume in the reaction is very small, maximum 300 microliters, which of course means that we are generating a very small amount of waste as well. And with this technology, you are able to do multiple tests simultaneously. So speeding up. pH, I already mentioned. This is an optional module which can be used for pH and conductivity. You can get more details from our partner Mia, who's worried about the time. I just wanted to show you this list of ready-to-use assay kits that we have in our offering. So on the column Analyte, you see the parameter that can be tested. And then you see the international reference method to which we are benchmarking the methods. So just to get you an idea that these are very well-known standardized methods, which we are simply automating. So we are taking the manual workload away from you. I also want to highlight here that the reagents and also the instruments, they are manufactured in our Thermo Fisher site in Finland. And our factory is ISO and FDA cleared, or ISO certified and FDA cleared sites. So we do have multiple ISO certificates and FDA clearance, meaning that you can really trust on the quality. I did want to show you a customer video, but I'm afraid that I don't have time for that. So sorry, I have to jump to the next slide. I think Mia will be happy to share this video with you and talk more about the true life customer cases. So we jump into the benefits slide. This is the last one, Mia. Speed of analysis. Of course, we do multiple parameters simultaneously, including pH and conductivity, and the single instrument system. You get more done with less. So a very small sample volumes, very small reagent consumption, and very small waste generation. Robust instrumentation. We don't get the cross-contamination because of the disposable cuvettes. The long-like xenon flash lamp in comparison to halogen lamps that we see often in automated instruments. And then the ease of use. You don't need to have highly skilled operators. Built-in barcode reader, and then there is this LIMS option. So bidirectional LIMS can be connected to your laboratory information system. To summarize, what we are offering you is reduced cost per analysis, long system uptime and reliability. Our mean time between failure is the best in the market. And we are offering you the easiness of use and a true walk-away time. So you load the instrument, leave it running, let it do the work for you, and you walk away until you get back to collect your results. Thank you, terima kasih. That's pretty much everything I can say in Indonesian. I'm not sure if we have time for live questions now. Mia, maybe you can help me.
Hi, thank you, Liisa, for your presentation. Now we are going to go through some questions. Actually, one question has been already answered by Ryan. Maybe you can add more. So the question is about the total nitrogen.
Okay, I'm sorry.
Let's see. Yeah. So nitrogen method, does how many instrument or equipment do you need, or you only use one instrument, which is the gallery? So Ryan answered that the TK-in method, after sample digested with sulfuric acid offline, then the measurement can be done using the gallery system. Do you want to add? Mm-hmm.
Yeah, this is correct. So of course, for the Kjelda, there is the sample prep step, similar way as for the total nitrogen and the total phosphorus. So we somehow need to get the organic part digested.
Ya, jadi kepada Bapak Dedi, apakah pertanyaannya sudah terjawab, Pak? Jadi untuk metode total chiral nitrogen ini hanya membutuhkan metode preparasi dengan cara di digest sampelnya dengan menggunakan asam sulfat offline. Nanti kemudian sampel tersebut langsung sudah bisa dianalisa di dalam galeri analyzer. Apakah pertanyaan sudah terjawab?
Okay.
Yes, he said yes.
Yeah, I saw. Thank you, Daddy, for your question. Much
So we only, unfortunately, we only have 1 more minutes. Jadi untuk pertanyaan-pertanyaan yang memang nantinya Bapak Ibu mau kemukakan, tim kami hadir di live di DBN sampai dengan tanggal 27 November. Jadi bisa bertanya pada tim kami yang standby di sana. Tim sales kami ada 4 orang admin yang siap membantu pertanyaan Bapak Ibu. Kemudian untuk link dari recording dari webinar ini nanti bisa kami bagikan dengan cara Bapak Ibu mengisi Google Form yang sudah dibagikan di kolom chat. Ya, nanti kemudian untuk pertanyaan yang sudah masuk kami akan mengirimkan souvenir dari situ. Bapak Ibu dapat menuliskan alamat lengkapnya. Baik, apabila seminar webinar hari ini cukupkan hari sekarang. Terima kasih sudah join. Semoga webinar ini membawa manfaat bagi Bapak Ibu sekalian. So Liisa, we have come to an end of this webinar session. I thank you for your support and also Ryan. So we will see you at another time. Thank you. Good afternoon, everyone.
Thank you so much, everyone, for joining. Thank you, Mia, for inviting me. It's been a privilege to be here. Thank you.
Thank you. Bye-bye.
Bye-bye.